A straight twin engine, also known as an inline twin, vertical twin, or parallel twin, is a two-cylinder piston engine with cylinders arranged in a line along with a common crankshaft. Straight twin engines are primarily used in motorcycles. Other uses include automobiles, snowmobiles, jet skis, all-terrain vehicles, and tractors. The term parallel twin, vertical twin, and inline twin originally had specific meanings relating to the crankshaft angle or engine orientation. However, they are often also used interchangeably. Various crankshaft configurations have been used for straight twin engines, the most common being 360 degrees, 180 degrees, and 270 degrees. In the United Kingdom, the term parallel twin is traditionally used for engines with a crankshaft angle of 360 degrees, since the two pistons are in the same direction, that is parallel to each other. Vertical twin was used to describe engines with a crankshaft angle of 180 degrees, which causes the pistons to travel in opposite directions. The terms straight twin and inline twin were used more generically for any crankshaft angle. So today, in this video, we are looking at different crankshaft configurations and how they are used in the automotive industry. To go over these, let's quickly review how the four-stroke engine works. Four-stroke engines have four distinct strokes. There's intake, compression, combustion, and exhaust. In intake stroke, the air or fuel mixture suck into the cylinder as the piston goes down. In compression stroke, the piston squeezes into a compressed area before the spark blows it up. In combustion, the spark plug makes it go bang, driving the piston downwards. And then in exhaust stroke, the piston goes back up, sending the exhaust fumes out before sucking in more fuel. So in a single-cylinder engine, the engine rotates twice every time the cylinder fires. But what about a twin? They surely don't fire at the same time? Well, they could, but they usually don't. Before that, let's understand the difference between inline and parallel twin engines. The inline twin or parallel twin-cylinder engine is often referred to as synonymous, but there is a fundamental difference between the two. If we take straight twin as common for both inline and parallel twin engines, it would be easy to differentiate between them. Ideally, the inline twin engine is placed in line with the bike's frame, meaning one cylinder is kept with the face on and the other is kept behind it. Usually, this kind of cylinder configuration exists in early motorcycle models. In a parallel twin engine, the cylinders are placed transversely with the frame, a typical setup for a straight twin engine. If the pistons move together up and down, in other words, if they move simultaneously parallel to each other, that sort of setup is called a parallel twin engine. Let's start with the 360-degree angle. In an engine with a 360-degree crankshaft, both pistons move up and down at the same time. However, the firing interval is offset between cylinders, with one cylinder firing on during the first crankshaft rotation and then the other cylinder in the following rotation. That's why this engine has an evenly firing interval of 360 degrees. The imperfect primary balance is created in a 360-degree engine, is as per a single-cylinder engine of equivalent reciprocating mass. Early engines attempted to reduce vibration through counterweights on the crankshaft. However, later methods also included balance shafts and a separate weighted connecting rod. Compared with a single-cylinder engine, the more frequent firing interval results in smoother running characteristics, despite the similar dynamic imbalance. From the 1930s, most British four-stroke straight-twin motorcycle engines used a 360-degree crankshaft, since this avoided the uneven intake pulsing of other configurations, thus preventing the need for twin carburetors. The vibration was less of an issue for smaller engines, such as the Honda CB92 and Honda CM185. Larger engines, such as the Yamaha XS650 and Yamaha TX750, often used balance shafts to reduce the vibration. In 1978 to 1984, Honda CB250N and Honda CB400N engines also used a 360-degree crankshaft. The 2008 BMW F-Series parallel twin motorcycles also use 360-degree crankshafts, with a third vestigial connecting rod acting as a counterbalance and a rev limit of 9,000 RPM to reduce vibrations. In a 180-degree firing system, the cylinders move in opposite directions. This means that when one is going up, another one is going down. Piston 1 combusts as the second does compression, then piston 2 combusts a half revolution after piston 1 did, while piston 1 exhausts. That half revolution is the so-called 180-degree difference named after this configuration. Both pistons must go through exhaust, intake, and compression again, so that it makes a 540 degrees before the next. In a 4-stroke engine, the firing interval is uneven, with the second cylinder firing 180 degrees after the first, followed by a gap of 540 degrees, until the first cylinder fires again. The uneven firing interval causes vibrations, resulting in a lumpy power delivery. A 180 degrees engine also requires a separate ignition system for each cylinder. The advantage of a 180-degree firing system is that it's perfectly balanced, the pistons move against each other. However, the design creates a rocking couple that requires using a balance shaft to reduce the vibration. A rocking couple defined as the two forces equal in magnitude, opposite in direction, with a perpendicular distance between them. You feel this as vibration in a motorcycle. The engineers counter with a counterbalance shaft in a modern parallel twin, like in the Kawasaki Ninja 650. A 180-degree straight twin engine has a secondary imbalance, similar to an inline-4 engine. However, the lower reciprocating mass means that this often does not require treatment. A 180 degrees crankshaft engine suffers fewer pumping losses than a 360 degrees twin, because the displacement of the crankcase is relatively unchanged as the pistons move. Two-stroke engines typically use a 180-degree crankshaft, since this results in 2 evenly spaced power strokes per revolution. In the 1960s, Japanese motorcycle manufacturers favored using 180-degree crankshafts, since the increased smoothness allowed higher RPM and higher power outputs. For example, the Honda CB450 180-degree crankshaft engine has a similar power output to modern British 360-degree crankshaft engines, despite having a smaller displacement of 450 cc, compared with 650 cc. The Yamaha TX500 and the Suzuki GS400 had a 180-degree crankshaft and a balance shaft. Since 1993, most Honda straight-twin motorcycle engines use 180-degree crankshafts. Going into a 270-degree application, or what others refer to as a crossplane crankshaft, just like the 180-degree parallel twin, both pistons are situated side by side. However, as one piston goes down, the second piston follows suit 3/4 of a rotation behind. This also results in an uneven firing interval. However, the interval at which both pistons go through the power stroke is much smoother, resulting in a more direct throttle feel. In this, the second cylinder fires 270 degrees after the first, followed by a gap of 450 degrees until the first cylinder fires again. This is the same pattern as a 90-degree V-twin engine, and both configurations have a similar pulsing exhaust sound. The pistons in a 270-degree straight twin engine are never stationary simultaneously, as per a 90-degree V-twin engine, thereby reducing the net momentum exchange between the crank and pistons during a full rotation. The advantages of a 270-degree firing order are that it's somewhere between 180 and 360. It has less primary balance than a 180-degree engine, but less of a rocking couple. It has more balance than a 360-degree engine, but has more rocking couple. Firstly, the most interesting thing about a 270-degree crankshaft twin is that there's never a piston that's not moving. In 360 and 180-degree configurations, there's always a point where a piston is either at top dead center or bottom dead center, and thus has to start moving again in the opposite direction. Yamaha calls an engine's effect never stopping removing inertial torque. They call it a feature of all their crossplane concept engines, starting with the inline-4 of the Yamaha R1 from 2009. Secondly, a lot of customer research by companies shows that the vibrations produced by a 270-degree configuration are pleasant. People enjoy the net effect of the slightly lumpy sound, even though you can make almost any engine sound interesting, and it's quite subjective anyway. An imperfect primary balance is created in a 270-degree straight twin engine. Due to a combination of free force and rocking couple, a balance shaft is often used to compensate for this. The secondary balance of a 270-degree engine is perfect. However, the configuration does result in an unbalanced rocking couple. Engineers have to use counterbalancers to reduce engine vibrations. Most parallel twins, all modern ones, have counterbalancers to eliminate vibrations. These forces can produce vibrations if they are not balanced. Engineers use balance shafts to balance the primary forces and the rocking couple that can be left if no balance shaft or only one balance shaft is used. Secondary reciprocating forces cancel each other out in a 270-degree crank layout. That's the magic of always being in motion. The first production 270-degree straight twin motorcycle engines were fitted to the Yamaha TRX 850 and Yamaha TDM. Later examples include the Triumph Thunderbird, Norton Commando 961, Honda NC 700 series, Yamaha MT-07, Triumph Thruxton 1200, and Royal Enfield Interceptor 650, and Continental GT. So that's it, thanks for watching. What do you think about these crankshaft angles? Which is better? Let me know in the comments. If you want to know about different types of bike engines, then watch this video.